Hey there YouTube, this is my video on Peltiers and heat sinks. It's almost more about heat sinks than it should be Peltiers, but whatever. So these are all CPU heat sinks. This is a Zalman heat sink. I don't know the exact model number, but it says it cools about 300 watts or whatever is making the heat. This one's a Thermal Right Co-Gauge True Spirit, whatever, 120 millimeter. Roughly, that's the name. And this is a Freezer A30 by Arctic Cooling, not Arctic Silver. They make thermal paste. This one, in theory, is the best. It says it can cool 320 watts. Big heat pipes. Now, I did some calculations and writing. I don't like writing. About the heat pipes on these. So starting with this one. This one physically has 3 heat pipes, 1, 2, 3, because they go all the way around this and come back to the base of this. But all those 3 are kind of doubled back, so it's like having 6 heat pipes, I guess. But Zalman says that the heat pipes on this heat sink are composite heat pipes, which combine 2 technologies of heat pipes, apparently. They're supposed to be 1.5 times better, 50% better than normal heat pipes, which equals 1.5% better, or times better. So it should be the equivalent of 9 normal heat pipes. This one here, this one, the co-gauge one, I'll call it that. Again, it has 4 like physical heat pipes, but since they go back, it's, I guess, the equivalent of having 8. So I'm going to say it has 8 normal heat pipes compared to this one's 9, in a way. Now the Freezer A30, again, it has 4. Sorry, burping. 4 physical heat pipes, but they're 8mm heat pipes. And this is also direct touch technology, where the heat pipes are directly on the base. They are the base of the heatsink, as opposed to these that have metal between. This one's like encased in metal, between the whatever's producing heat. In this case, Peltiers, and the heatsink itself, whatever. So the 8mm heat pipes, which these are 8mm compared to these are 6, if you're wondering. And in theory, that should make them 1.3 times better, or at least larger for sure. So it should be about 10 heat pipes. You can't have half a heat pipe, so too bad. Find it somewhere else. So I don't think that actually makes them 1.3 times better. They're just 1.3 times larger. That should mean that they are slightly better, but it depends on how much. If they were the technology of these that are 1.5 times better, and they were larger, that would be really awesome, but I have yet to find a heatsink that has that. For thermal paste, both of these use Thermal Right, the chill factor. I ripped off the label so I could see how much there was in there. I've used quite a bit. Not too much on these. I know not to use too much. I just want a thin layer. Whatever, so both of those use that, including this one here that has 2 Peltiers. I have it on the bottom of both Peltiers. This one here I just got yesterday, so this is, I guess, better. Probably should be better than this stuff. Thermal paste, it's Arctic Cooling MX4 thermal paste. It's supposed to be similar to their MX2 and 3, but easier to spread. I don't know anything about the other ones other than that, really. I don't use a lot of thermal paste, even though I do have a small collection of it from all the heat sinks I've got, really. So this stuff is supposed to be pretty darn good, and that's what I've used on this. I couldn't use this stuff, unfortunately, on either of these, because these are older, not really older, like when they were made, but I bought this one like over a month ago, and this one even longer ago, so I didn't have the chance to put this stuff on it, because I only got this yesterday, and this came with it. Tiny syringe, though. It's only half a gram. My power supply here, 12 volts, 19 amps, so 223 watts. I already did the math, I didn't just do that. The bottom Peltiers on these are 60 watt Peltiers, and this one has another Peltier on top, as you see there. That is a 24 watt Peltier from a smaller beverage, whatever, pop can cooler for the car. I think they're all supposed to be 15 volts, but 12 is close enough. Just the amp draw should be a little bit lower, I think. So yeah, whatever. This one, like, if you know anything about Peltiers, and if you don't, well, I'll make a really long video if I start explaining it, so go search it yourself on Google, not to be mean. Peltiers have a temperature difference between the hot side, which is on the heatsink, and the cold side, which is on the top. Usually, unless you want a heater, you can actually boil water on these pretty fast. The temperature difference for normal Peltiers is around 70 degrees Celsius, maybe 60 for older Peltiers. These are relatively new, kind of old, not used very much. So this doesn't actually make the temperature difference 120 degrees because when you start putting load on Peltiers, the temperature difference is much less. With these, it's almost as much as it could be, which is actually about 60 degrees for both of these. Well, this one's about 90 degrees, so it doesn't make it fully better. A drop of water on it, dry that. I think that's water. Oh, it's not, wow. So the temperature difference on this is much higher because there's two Peltiers. You can't have two of the same size Peltiers. Well, I mean, you could, but it's not a good idea because if they're the same wattage, you overload the bottom one because they don't use that full 60 watts for cooling. A lot of it turns into heat. So even this should have a smaller Peltier on top, but it works pretty good. Or pretty well, whatever. So I have my thermal gun here, infrared. It reads down to -40. And these get pretty cold, so mostly this one gets the coldest by far. Almost -60. I figured it out. I'll tell you how I did that later. So this reads only down to -40, so well, you'll see why that becomes important. So I'll turn them on here. This has a nice switch on it there. Turns the whole thing on. The fan on this one's a little bit noisy. I think it might be kind of loose. This is already at almost -20, getting there. And this one's a little, yep, colder than this one. It's hard to get exactly because I have to go like this over to this one, but they're pretty close. Well, this one is, yeah. Switch hands quickly. And it will keep going about another 20 degrees, and you won't be able to see it past the next, like, 3 degrees. The -16 there, this thing has a feature in it where it records the maximum, like, whatever, the high temperature it's just been reading, so if I point it around, whatever, like this, see, it can be currently reading 28 degrees, but the high somewhere here was 30 degrees. Or it just changed because I restarted it. So you're looking at the top temperature if you're wondering. That one's doing pretty good. Well, this one kicks butt. Get the frost off of these. It'd be nice to do this in like a, ow, my finger sticks on it, like some kind of climate control, whatever, environment, where you could have the humidity level really low, which would probably start, I've heard you can get nosebleeds if the humidity's too low, but maybe just have them in like a small chamber or something that humidity's like really low so you don't get any frost buildup on them. Or just have a dehumidifier, which these are, kind of. You can actually make small dehumidifiers, which I actually did. So this one, maybe wondering how I figured out the temperature difference. Seeing as I can't measure it right now, because you have to know the temperature of the cold side and the hot side, which I just used the base of this because it's actually warmer than the heatsink, which means it should be more accurate because you want the highest temperature, even though you don't want high temperature. It's more accurate. It's hard to explain. But what I did to measure it was I turned this fan off, and while that happens, the heatsink starts to warm up slowly, because you have to warm up like a couple 100 grams of aluminum, whatever, and all this copper and more copper and aluminum. So when the base of this gets to 50 degrees Celsius, measured by my thermal gun, the top, the cold side, just starts to go a little bit above -40. So that should make the temperature difference around 90 degrees Celsius. I don't use Fahrenheit because I'm in Canada, if you're wondering why. So, yeah. Just because I have a little time here, just for no reason. The fan on this one is the loudest. I'm not doing a heatsink review here, by the way. It's just kind of like heat sinks. I kind of collect them almost. As you see right here. The fan on this one's the loudest. I don't know the exact rating, just because it moves a lot of air, and it's actually a 135 millimeter fan as opposed to both of these that are 120 millimeter. This one kind of makes more of a like whirring sound when it's on. I don't know why. It's just maybe the shape of the blades. And this one's just like quiet overall. So it's kind of in order here, like loudest, quieter, quietest. I just kind of did that by accident. Well, -32 I saw. Switch hands again. Point this around a little. I thought I saw -33. I might just be having illusions or something. One thing about this heatsink is, I don't know if you can see that, but the Peltier hangs over the edge of it just a little bit that way, and a little bit in the corners too. I don't care too much, but you know, it's like when you start getting into really big Peltiers, which I will soon, hopefully, like a whatever 200 watt Peltier, which would be like more power than all these together almost on one. It's kind of weird how they do that. You might start getting into problems where the corners of it, like the middle might be nice and cold because it's right where the base of the heatsink is, but the corners might be warm because it's kind of, you know, off a little. So one way to fix that, I'll have to look on eBay because I love eBay. Look for a square of copper that's not like copper foil, but like a little plate of copper. It's like a couple millimeters thick, maybe like 5 millimeters thick. Would be a nice lump of copper almost. That's 40 millimeters square. I don't use inches, again, I'm in Canada. Metric system. And have the Peltier on top of that, so that the heat kind of like comes from this square and then gets down into the base of the heatsink. This one here is kind of odd. Like when I was buying it, I wasn't sure if the base was big enough, and it fits. It's hanging over this edge because I kind of, when I was putting the tape on, it started sliding around a little because the thermal paste is really slippery. At least the stuff I got. It's not thermal glue. I don't want thermal glue because I don't want to permanently attach it to one of these unless I really decide to, which I'm not going to. The base of this is almost exactly 40 millimeters square. Well, not like square like that, but it's 40 millimeters in a square. This one, you can't see it really well, but even though it looks like the base does fit, it doesn't actually. The base, there's this little bit on it, again made of copper. It's still the same physical piece, but it extends up just like a fraction of a millimeter for no apparent reason, and that actually it's a little bit smaller than this Peltier. It's like about 38 millimeters. Well, all these Peltiers except for this one are 40 millimeters square, so it's just a little bit too small. So you kind of take your pick. This one is square and it's too small both ways, and this one's more rectangular and fits one way but doesn't the other, so it's like whatever, pretty close. I'll have to find some pieces of copper. That'd be nice. A piece of copper would be nice for this piece too, because I don't think that the ceramic on top of these, because these all have ceramic on top, you can actually get kinds that have the Peltiers have copper plates instead of ceramic plates. Those are pretty awesome. More expensive, of course, overpriced. But you could have a plate of copper between two of these Peltiers, so that the heat from the bottom of this Peltier gets spread more evenly, so it gets cooled better. What I did actually have before, until I kind of rearranged this a little, was I had this. This is a heat spreader for an AMD Athlon 64. This little Peltier, perfectly. It's, even though this isn't quite square, it's kind of rounded. Like, not perfectly, but I mean, like, there's like less than a millimeter to spare on each side, because this has this little ridge that sticks up, and this side fits almost. See, it's not quite wide enough to fit all the way. This is almost pure copper, but you have a magnet out of nowhere. It does pick it up a little bit. I need a stronger magnet. I do have stronger magnets, just not with me. So this does have a little bit of probably nickel in it. I doubt it would be something like cobalt that's magnetic. It could be iron, but that might rust, of course. I'm not sure. So it does have a little bit of ferrous metal in it, and maybe some aluminum, because it doesn't look like copper. But I did scratch it in a couple places. There's some really tiny scratches there you can't see, and it looks quite coppery, so it might just be a coating. That's what I'm hoping that that's what it is. Yeah. For some reason, anytime I try and make a video about Peltiers, it ends up being almost 20 minutes long. But I can't help it. I put a lot of information into videos, I guess. I don't like YouTube videos where people don't talk at all. It's like, what are you doing? Explain. So I like talking a lot, I guess, to explain what I'm doing and all that. If you have any questions or anything about Peltiers or my setup here, I don't know everything about Peltiers, like precisely how they work, like what actual materials inside there. I know it's usually there's a material called bismuth telluride, which is an efficient thermoelectric material, relatively efficient. So yeah, I don't know everything about it, but I know quite a bit. So if you have any questions about stuff about Peltiers or my heat sinks or anything like that, go ahead and ask in the comments below. So yeah.